Record, and we are now recording. So the two things I'm going to go over tonight with you before I let you take this, start part one of the test, is the screwdriver assignment number 5, and then of course our final project. The assignment number 5 looks like this. It's been posted on our Canvas for a few days now. You are actually going to build this screwdriver, and I'm going to show you or demonstrate how to do that this evening. It's pretty straightforward. It's not that difficult. The difficult part of this assignment is you're going to take the screwdriver after you've built it, put it on your NHTI template like you see here, and fully dimension it. You're going to have this on the left side. Now, the second part of this is you have to go in and actually do some research or measure a Phillips head number 2 bit. And you're going to do a Phillips head screwdriver using the same handle that we have on the straight slotted screwdriver. You're going to do a Phillips head screwdriver, and you're going to do the exact same layout as I have over here, but you're going to have the Phillips head over here. Notice that you should label them too. If they're two different files that on the same paper, that should be labeled differently. So essentially you just gotta, we're gonna draw this one tonight. I'm gonna show you how to draw this one tonight, so it shouldn't be too bad doing that one. And then you have to do some research as to the size of them and try to figure out how you're gonna build that Phillips head. The Phillips head can be challenging. It can be challenging. So let's get started. Here we are in SolidWorks. That should look familiar to you by this time. I know most of you are doing very well with it, so that's good. We're going to start by just going to a new part file, as we always do. And then I like to check down here just to make sure I am in inches, pounds, because it's not metric, it's the US customary system. And then I'm going to start with a new sketch on the front plane, like so. Now, how do you begin this one? If I'm looking at it, I'm going to start with the handle, and I'm going to use a revolve command to do the handle, and then we'll go from there. But we'll do the revolve command for the handle. I'm going to start with just a rectangle. I'm going to add these dimensions. Now remember, when you do a revolve, even though it's 0.75 diameter, you got to do half of it, right? You got to, because you're only going to do the radius. This is going to be 3.5. That looks pretty tall. I'm going to throw a circle over here. Interesting enough, and you'll see where this all comes together in a minute here. And then I'm going to dimension from here to the center of that circle. That's going to be 0.375. It's 1 inch up to the center of that circle. So we got the two location dimensions. Actually, I'm sorry, it's 0.75 up. And there's a curve on the top, so I'm just going to add a circle on the top that has a radius of 0.375. I'm going to use my extend entities to extend that part up. Then I'm going to use my trim entities to get rid of everything I don't need. So I created my profile. Once you finish your profile, you check, finish your sketch, and go over to revolve feature. Should come right in, you just pick the edge of it and it revolves it right around. And you got the handle. You got to keep moving the zoom box around. Sometimes it gets in the way. Now, after we got the handle, typically what I do is I'll flip it over. I'm going to throw a sketch on this surface. So I go sketch, and then I'm going to draw a circle. Now, interesting enough, I got the shaft of the the screwdriver comes out in that direction, but I also need the hole of the screwdriver. So I'm going to make the hole like a couple thousandths of an inch bigger. So I'm going to start by just simply, I know the shaft comes in there is 0.25, but I'm going to make the hole just a couple thousandths of an inch bigger. All right, I'll go back and look at this isometrically. I got that done, so I'm going to go back and I'm going to cut a hole all the way up through it. As a matter of fact, I think it goes up 3 inches. I have to go back and look at my measurements. Yep. All right. I think I'm going to make that 3.5 inches. So it's going to come right up to where it turns to a round thing. So instead of it being 3, you noticed I just went to edit. I went 3.5. So it goes all the way up. If you're looking at it from the front view, right up. Oop. I must have hit escape. 3.5, enter. Check. So all I did with that is really just make this hole. Now I'm going to go back and I'm going to quickly put in the shaft. I got a sketch there. I'm going to put a circle in there. The shaft is going to be slightly smaller. Should be 0.25. This is really what we call an interference fit. There's, I mean, a couple thousandths of an inch. It's definitely going to have a hard time, especially if you put glue. In most cases, the handle is it's plastic, so it's formed right around the shaft that comes up through there. So I've given that a dimension. Go back and extrude. Now I'm going to extrude it back the same length. 3.5. And now I'm going to do this again. And I have a sketch on there, so I'm going to do it again. I'm going to make sure that I have the right circle. Sometimes it's better to make that circle bigger or smaller than it needs to be. 0.25. Does look a kind of repetitious to keep doing it that way, but now I'm going to extrude it out. And we're going to come out 2.5. So, yep, we got a question. Let me just go to my chat here. Yes, it would be just as easy to extrude in both directions. But what I found is when I was looking at it, I was thinking I could extrude it both directions, but it's going to come 2.5 out, and I did it 3.5 back. It'll extrude it in both. A mid-plane extrusion will be even in both directions, like if I did 7, 3.5, and 3.5. But as it comes out, I only need 2.5 out, so that's why I did it differently. That's a good point, though. And I was looking for that command because I know in other 3D modeling softwares it allows you to do 2 different directions at 2 different distances, so opposite directions at opposite distances. So now I'm going to add another sketch right on the end of this, and this is where we're going to make the straight slot of the screwdriver. I put a sketch on there. I'm going to turn around so I can kind of see it. And I'm just going to draw a circle. Technically, I shouldn't have to draw a circle. I could do what they call convert entities. If you hit convert entities, it's supposed to project the circle. So I actually get that 0.25 circle, and I shouldn't have to make the circle. I just kind of old school. I like to make sure I have not only the sketch on there, but I want to make sure that I have the right size circle that I want, including the sketch. So now I have this circle on here, and I'm just going to get out of that. Now, in order to do a loft, I've got to have at least 2 sketches. It could be more than 2 sketches, but I also need planes. So I'm going to go up here and I'm going to use what the reference geometry, and I'm going to use my planes. Simply by picking this surface right here, notice it offset it. And usually it offsets at 0.1, but because I had practiced this earlier, it remembered that I did it at 0.5. So I'm just going to say okay with 0.5. And then I'm going to go and do it again. This time, it automatically picked up plane 1, 0.5, and that's it. So I have 2 planes coming off from this surface. I know the distance from here to the last plane has to be 1. That's why 0.25. This actually looks more challenging than it is, because now I'm going to do a sketch on plane 1. So I'm going to start a sketch there. You'll notice that the origin icon right there, a lot of times I'll turn it around so I can see right on what I'm doing. And the key here is that when you do a rectangle, you do a center point rectangle. So I can pick it right up, bring it out, add my dimensions. I know it's going to be centered. 0.15 here. I believe that's 0.35. I'm going to finish that sketch. Once again, because we're doing a loft, going from one to the next, I have to have multiple planes and multiple sketches. So I'm going to add another sketch, but I've added this one right now. Notice how it jumped back to that one. So I'm going to just say, I don't want to do that. I'm just going to click on this one, and then I'm going to say start new sketch. So I make sure I'm right on that one. Sometimes it jumps back to the old one. Once again, center point rectangle. Pick the center, bring it out. The end slot is going to be thinner. Notice I'm just adding the dimensions. All these dimensions, as you'll see, come right off from. Gotta watch what I'm picking there. There, get the right line. This is going to be 0.25. So they all line up. I have 3 sketches right there. And that's how we're going to create the straight slotted part of the screwdriver with these 3 sketches and a loft. So once I finish, then I'm going to go to my features, loft. Now when loft comes up, it automatically picks the first one for you. You know, I've had problems with that before. I kind of like to do it from the outside in. I'll just back that off. I was playing with this earlier, and I thought it worked better if I pick this one first, slot, and that. Usually it picks them right up. All right, we're going to go back and do loft again. Pick the top. Pick the first sketch. I don't like how that keeps coming up every single time. We'll do it again. Oop, I don't want to do a loft cut. I'll pick the outside one first. Oh, it's going to twist it on me. You know, I just practiced this to make sure it didn't do this on me. Isn't that always the way it is? Sometimes it's best if you just pick it here. Pick regent. Pick that regent. Check. Then I'm going to pick this surface, and then I'm going to finally pick the top of this one. Just see how it keeps crossing those lines. Yeah, that's what happened last time when I did it. It's funny how it did it that time too. I've done it this about, that's not exactly what I was hoping for. See how it curved it around like that? So we're just going to right click, delete. If you delete it, it's not going to delete your sketches or anything. It's just going to delete the actual loft part of it. So go to loft. We do it one more time. We should be able to just click on them. Boom, 2, 3. Wow. You can do loft from centers. You can do loft different ways, but you know what? Pick regent. Should just be able to pick them. That loop to that loop to this loop. There we go. And that's what you're supposed to get. Just in the nick of time. So once you've got the flathead part of it with that 3-point loft, as you can see, that's kind of a pain sometimes. And I'm just going to get rid of this. Not getting rid of it, sorry. I'm turning off the visibility of plane 1 and plane 2. Just going to click on it and hit the eyeball there, hide it. The other thing I like to do at this point, and you don't necessarily have to, is I change the handle color, the revolve. It's going to come up, and I'm going to change it to red. Makes it stand. Oh, look at that. I'm trying to move too fast here for you guys. I'm not changing materials at this point. I'm just changing the handle color. I think it looks better that way. Last but not least, if we're going to finish this off, you have to put the NHTI logo on here, and it's much like when you do the final project, the NHTI Cool Cups project. You got to put a logo on here too. So I'm going to start by just putting a plane on, a reference plane. And I'm going to say I want the reference plane to be, this is how I look at it. Do I want it to be on the front? Yeah, I'm going to pick the front. And notice how it automatically wants to offset it out. It says 0.5. The truth is 0.5 is fine as long as it's on the outside. As long as it's not inside the actual handle, you're fine. So I have a plane out here. Now I'm going to take that plane. I'm going to just throw a sketch on it. Just say sketch on the plane. And I'm going to look at it from my front view. This is an interesting little trick, and it takes a little while for you to be able to see this. But if I'm going to put text in, and I want that text to go straight up, I have to put some sort of reference line here that goes straight up. So I'm going to just throw a line in here. And I'm going to put it right on the edge here, about like there. That's a guide. And I'm going to say I want that line to be for construction purposes. Notice how it changed it to a dash line there. So I have my line there. Now, once I have my line there, then I'm ready to do my text. Because the first thing it says, oh, look, it found the line, and I want to make sure it's centered. So just make sure you got the line. Look, it's already picked over here. I didn't even have to pick it. And now I'm going to type in NHTI, all in capitals. Now notice it came on the other side. You can flip it around. You can do a lot of different things, like it'll jump to the other side. If it's going the wrong way, this will click it that way, and it goes that way. The important thing is that you say centered, so it's centered on that side. And it's really kind of small, so I'm going to make it larger. I'm going to say use document. I'm going to deselect that, and I'm going to be able to go in and choose whatever font I want, and I'm going to make it as big as I want. You can use regular point size if you have a knowledge of font point size, or you can give it a specific unit height. There it is, NHTI, and it's, if you look at it, it's on that flat surface right there. Now you could go back, if you highlight this, you could spread them out more, bigger spaces in between it. There's a lot of things you can do with it, but I'm pretty good with that. And then, which is really neat, is you're going to be able to wrap it. It's called wrapping it to the handle. So I'd go up and I'd say, see here, wrap. When you do wrap, you just pick the surface. See, it already picked the sketch for you. I think that must have been sketch 8. Look at that. Although, pick the surface, and look, it just automatically wraps it right on there. They give you a preview. 5/1000 of an inch is fine. And then you wrap it in there. And it wraps it to the handle. You're going to be able to do that on your final cup design too. You're going to be able to put NHTI or whatever. You can even find logos and stuff on the internet or on the websites and be able to do that. Once again, I'm going to take this and I'm just going to I'm going to hide it so it looks. And you have it embossed on the handle. And that's how you're going to be doing your flathead screwdriver. Any questions about the flathead? I saw somebody had, Patrick said he had his hand up there. So let's see what we have to say. Patrick, go ahead and say something if you have a question.
No, I accidentally clicked that.
Okay. So
Sorry about that.
no problem. No problem. So now, once you're finished with that, then obviously you want to save that as CAD assignment number 5, flathead or flat slotted screwdriver. And then you're ready to start doing the second part of that. The second part, of course, is to design the Phillips tip. So everything from here up really is going to be the same. So all you got to do is the little Phillips bit tip on the end of it. So any questions about CAD assignment number 5? I think from what I understand, the most difficult part of that is trying to get the measurements for the Phillips tip. So if you have a number 2 Phillips head screwdriver at home, I suggest you just take some measurements off from that. Even if you're just using a ruler that goes down to a 32nd of an inch, you should be able to get a pretty good measurement on terms of how big that is. So, because I've had students look the internet over and they had a hard time finding that. Now, of course, you're not done yet. You still have to go back, open up your NHTI templates. You're going to put that on. So when you pass that activity in, you're going to have this on one side, fully dimensioned with the isometric. And on the other side over here, you're going to have your Phillips head, title, isometric, and fully dimensioned. Should it include the NHTI label? Yeah, you should be able to. You should try the wrap. You should try the wrap. Any questions on that? Other than the loft, it worked out pretty well. The loft is tricky. The loft is tricky, as you saw. It took a little time. It's funny because I think every time I've ever done it, the loft came out fine. But I was playing with it today, and every single time when I went through the loft, it did exactly what it did this evening. It was jumping back and forth. So now that you know all about CAD assignment number 5, I want to share with you our project. Yes, our final project. And our final project is called, let's see, I'm going to link it right into this. The final cool CAD project. There it is. Looks just like this. You are a product designer hired to create a specialty themed cup for NHTI's bookstore. The beverage container must have a unique design that is appealing to members of the NHTI community. Your design is a specialty product intended to sell to a target audience. And I gave you 2 examples of what's already on their website. They already sell this. It must hold a 16 ounce bev, so it has to be slightly larger than this mug. It can be made out of polyethylene, which is basic plastic, ceramic, stainless steel, basically almost any material you want to use for a mug, or it could be a water beverage container or whatever. But it must display an NHTI like this logo, or it could be just the NHTI logo, but it should display it. In this activity, you will research, brainstorm, design, and model an innovative NHTI beverage container to be sold at the school campus store. Start by researching. That means you'd probably go to the campus store. That would be right here, and start to see what they already have. Can you model your design off something that's not in the store? Sure. You could come up with your own design. You could model your design off something else that you've seen before that's kind of cool. It could have top, it can have lids, all sorts of different things, pour spouts. This one is just a container with a lid. It could be a ceramic mug if you decide that's what you want, that's what you really like to do. So to begin, once you've done your research and you've kind of got an idea, you're going to require 3 brainstorm sketches, much like we did with our reverse engineering project, you had to have 3 brainstorm sketches for your unique new design for your parts. You're going to do the same thing. These sketches don't take a lot of time. They're just 3 different concept sketches. And then I do want a really good quality final design concept sketch with all the parts labeled and tonal shading. So basically, it's a picture of your final cup design, and a good quality one, tonal shaded, just like we did. We went over concept sketches. And then it says right here, I crossed it out, you don't have to do multi-views of your parts. When we did our reverse engineering project, you guys started out, I took a bunch of pictures, and you had to do multi-views of your parts with dimensions, and then we were going to go back to the lab and use our dial calipers and take those dimensions. You don't need any multi-view sketches. You can jump right into building parts right in SolidWorks. Our time constraints are pretty tight. So start building parts right after you come up with your final design. Then you're going to do your assembly. You're going to do exploded view. You're going to do an NHTI cover sheet. Basically, that's the one we've talked about many times. You're going to have the exploded view, the assembled view, the parts list, and the balloons, the labels. Could your cup be just one part? The truth is, it really could, like a mug or something. If it's ceramic, it could be one part. That's a possibility. That would be the basic designs. That would be most basic designs. You do have to do multi-views of each individual part. And this is where it becomes interesting. I want you to do a cost analysis based on its weight. So whatever you do to choose for your material, ceramic or whatever, I want you to see what you can come up with for a price based on its weight. And remember, you can evaluate the specs just like we've done surface area weight. So you change your material over, right? Come up with a product name, slogan, design, right? Selling points. And then you're going to create a very, very quick presentation, a Google Slides or a PowerPoint presentation, basically selling it to the school store. If you came to NHCI and said, this is the mug that I've designed specifically for our community, these are the selling points, it holds this much fluid, it holds hot or a cold fluid, it has a cover, it can keep things warm for 10 hours straight, or, you come up with those type of selling points. And be honest with you, you can exaggerate a great deal if you want to. It's up to you. So make it kind of fun, right? It's a sales pitch. It's going to be very short sales pitch. It should have a name for your kind of cup, whatever name it is, a slogan maybe. You know who your target audience. You're going to have a cost. So when you're figuring out costs, a lot of times what I like to do for just basic cost, whatever the cost for the materials, typically it's got to be doubled to make 50% profit. So if your materials cost $5.50, you should be charging at least $11 for it. So keep that in mind so you can make something of a profit, right? Here's our timeline. The final project research, this is today. You should start this process this week, right? So this week we should be doing research, final part sketches, all that kind of stuff. I would say even to the point where you start building your parts this week. And it won't take that long to build the parts, depending on how complex the seals are on the cup and stuff like that. You do exploded view next week, get all that done. If you can get all this inventor stuff done by the end or by next week sometime, then you're being good shape. All you got to do for our last class is have that presentation ready. And on our last class, you're going to have all your work submitted by that time before class even starts. And each one of us is going to share our presentation through the Zoom session. So I'm going to twitch it over and you're just going to go share your screen and you're going to show us, hopefully your presentation is going to have tons of pictures in it. It's going to be kind of fun. And the presentations probably end up being maybe 4 slides or something like that. As you can see, the deliverables are here. Cover sheet. I like a cover sheet on the document package. brainstorm sketch, your concept sketch, SolidWorks cover sheet. That would be included the assemble, exploded balloons, parts list, multi-views, fully annotated, and then the presentation. You don't have to have a hard copy of you just share the presentation with the instructor. All the rest of these, I need either images of them or JPEGs of them. Do not send me SolidWorks files. It's so frustrating. Sometimes I go to open them and they look good and then they disappear within a fraction of a second. And I can't grade them because I don't have all the parts that go with that drawing file. So don't even bother sending me a SolidWorks file. Make sure they're a PDF of it. So you save as and you switch it over to PDF. So that is our final project, which is due technically 2 weeks from tonight. So 2 weeks from tonight on May 7th, that's our last meeting. And that's when we're going to be presenting our designs for our cups. Any questions about that activity? It should be fun. I mean, you got a cup in mind, you got a favorite cup in mind. If you got an Eddie cup that you want to model and sell them at the campus school store, do you have to make it up from scratch? No, you could find one that you really kind of think is cool and try to model that one or something similar to it. Maybe add a handle to it. So make it fun. Make sure you got a logo on there, meets the requirements, and go with it. Go with it. Shouldn't be too bad. All right, on a second here. Do I have a YouTube video for the threads? How to cut threads, you mean? If you use the thread, I don't think we have reviewed designing threads. Threads actually, I debated about going over threads and fasteners tonight. We talked about holes and tapped holes and thread notes and stuff like that, or hole notes, which covers some parts of threads. But I was saving that for next week, threads and how to cut threads, because actually SolidWorks will cut threads. There's actually a thread command. So if you applied a hole and you gave it, it's so many threads per inch, it'll actually cut that for you.
I was thinking more like the plastic water bottle with a threaded lid.
Oh.
For the final project specifically,
right,
something like
right.
that.
Well, it's interesting you say that. That's exactly what I was. Chapter 8 is called Threads and Fasteners, and I was gonna go over that next week. So if you can do everything, kind of get an idea of the design that you want, and then hold off and cut the threads on it, we can do that next week too. So now, in a minute here, I'm going to let you guys go so that you can do this. You have to go, and it may be easiest if you just go to our, I shared this with you. So the first thing you're going to do is go to socrative.com, and then it's going to ask for a room number, and you're going to type in X4205, and you're going to take the multi-choice quiz, the first part. And then when you're done with that, you're going to click on this link, and you can print it out if you want or whatever, but it's going to take you to this file, part 2. And you are going to be building this part in SolidWorks. Then you're going to open up an NHTI template, right? And you are going to go and actually create this multi-view isometric one, and then fully annotate it, including the section view. So when you pass it in, which will be a PDF, of course, you're going to pass in. It should look just like this, of course. The title block information will be changed. But this would be part 2 of the actual test. So first step, finish off the Socrative part. Next step, go through and do part 2 of the test. I will give you 24 hours to do part 2 of the test. So as long as it's submitted by this time tomorrow night, I'm all set. You just attach it to an email and email it to the NHTI address or the my address you've been selling, email address you've been sending everything to. So Socrative first, then this, and then, to be honest, I'd probably start on get screwdriver done out of the way, and then maybe start working on some brainstorm sketches for cool cups, your cool cup designs. Questions? No questions. I'm going to pause the